This video is made by Daniel Ahmed for Big Data 3210 Macquarie University. This is an assignment and it was necessary to upload it on YouTube as well. So for the first task 0, we have imported some libraries, we've connected to the database, and then we've cleaned the bodies of the tweets. And we've outputted to see how the output looks like before going to task number 1. So for task 1, all of our tasks, task 1.1 to 1.4, we've used the codes that have been provided on iLearn. So for task 1.1 keyword extraction, we utilize the NLTK library and the rake_NLTK, and we import the rake object to define our function keyword extraction, and then whatever is outputted, we join it by a comma so that it's in somewhat a CSV format. And then we loop through all the tweets, and then we tokenize it and use port stemmer to reduce them to reduce them down to their stem words. And then we also try to remove the stop words. Here I've commented it out because stem words was resulting in highly inaccurate results. And then we update our database one by one, and we create a new column called keywords, which we can see through our Studio 3D as well. For our task 1.1 named entities, we define two functions, stem words, remove stop words, and then we've defined the function find entities, and the function then performs a part of speech tagging on the remaining words using the POS_tag function from the NLTK library. It filters the tag words to include only those that are nouns, singular or plural, like nouns, and also proper nouns, singular or plurals, and have a length greater than 1 to filter out any single character words that might be incorrectly tagged as nouns. And then we extract them into a variable by joining them with a comma, and then we loop through the tweets, and then we call this function find entities to perform on the tweet's body, and then we update our MongoDB one by one. Here we can see some of the output. I've looped through the tweets and just limited my output to 20 rows, and this is what it looked like. For our task 1.3, we use the GenSim library. We define the topic extraction functions. We tokenize remove stop words, and then the LDA model variable is assigned to the output model's LDA models.ldmm model method, which takes in the corpus and the dictionary as its inputs over here. And topics is equal to LDA.get model topic terms. After building the LDA model, the get topic terms method is used to extract the top 3 most important terms from the identified topic. The method takes 2 parameters, top ICID is equal to 0 and top n. We can change this top n to 10, 1, whatever, so it will change the output and the number of topic terms that are extracted over here. For our task 1.4 sentiment analyzer, we use the NLTK download rated lexicon, but the download is only needed once, and then we define our sentiment analyzer function. Within the function, an object of the sentiment analyzer class is created from the NLTK library. The object is used to analyze the sentiment of input text string. The polarity scores method of the sentiment analyzer object is used to compute a sentiment score for the text string, and then we loop through each of our tweets, and then we see what the sentiment is in each tweet body, and then we update the MongoDB accordingly. It creates a new column in our Studio 3D. We can view that, and we can view the output over here as well. So NU is neutral, compound, neutral, and it just limits the output to the first 20. For our task 2 frequency of words, we first extract the tweet's body into a txt file named tweets in text, which can be seen from here. And then we have our mapper and reducer function defined in word_frequency.py, which we can see we have one mapper function, one reducer function. And then we import the subprocess in the OS to define our input and output files, and then we assign it to result of the word frequency. We run our word_frequency.py against the txt file, and then we output a new txt file which is defined at word_frequencies.text, which would have all our output generated. Although we can, it does create a Word file named wordfrequencies.txt with the correct key value pairs, we can still show some output to improve our code. We can see the output over here, but we can also see the word frequencies over here as well. Task number 3, number of tweets by city. We use the GNIP and profile locations, and in profile locations we have the country and the locality, which we can confirm through our story30. GNIP profile locations address and address we have country code AU and then the locality. So our code is based on that, and we're checking if the country is AU. So first we're going to check if the country is Australian, and only then we're going to proceed. We're going to record the localities only then. And if the locality is in the address, then we store it, else we store locality is not mentioned. We then create a new txt file with this output saved, and which we can see in Australian tweets.txt. So we're only interested in the localities which we have over here. And then we go and then we import subprocess and define our input and output files. And then we have our py file tweet_city_count, which we can see here. We have one mapper and one reducer function, which maps the locality and sums. First maps the locality and then it sums the count of each locality. We can see that the output file defined here, city_tweets.count, does have every locality and the number of occurrences in the tweets. For task number 4, we create a new txt file, we extract the ID and we split it. We also extract the link in the object and we split it with a column. We can check story30, and in checking the objects we see that if we have the ID and the link, we can trace it back to the tweet and we can retrieve the other things such as the summary and the posted time if we have the link. So link and ID were used over here, and then we extract this and then we write it in a new file, and then we can see that our tweets and IDs and links have been saved as a txt file over here. This is unsorted. And then we have our MapReduce function, which we import with the subprocess. We define our input and output files. We check our sort tweets_id.py, which has one mapper and one function. This uses a default feature of MapReduce to sort them based on their IDs. And then we can check that our final sorted output is stored in sorted_tweet_id.txt. So this is our final output. For task 4.2, we define a conventional merge sort algorithm. The merge sort algorithm works by defining the input list into two halves recursively until each half contains only one element. Then the two halves are merged by comparing the first element of each half and appending the smaller element to the output list. This process is repeated until all elements are merged. We also have a vertex analysis for comparison, which was asked. So we compare the processing times and we give our analysis in vertex for task number 4. For our final task number 5, we import task bag, task array, and scalar and feature extraction and pre-processing. And then we use the keywords we've already extracted in task 1 into a txt file, which is here. And then we utilize the code reads a text file containing keywords using the task bag. Then it uses the count vectorizer and the TF-ID transformer from the scikit-learn library to calculate the term frequency inverse document frequency, which is the TF-ID score in our case for each keyword. After that, it sums the TF-ID scores over here in this line. And the n value here, the specific value of n, number of top keywords to display, is set by the user, and the code assumes that each line in the text file is a separate document, which in our case is a tweet, and each keyword is separated by a comma. So we have the top 5 keywords displayed, and if you want to change that to 10, we can do that over here. And also in our documentation, we have provided the limitations and the proposal for future improvements that have been asked in the question. So that's all. Thank you.